Ice is on this side. Ice is here. Ice, I am drawing a dot just below the 0 degree centigrade. Just below and just above makes a difference. Just below is ice and just above is water. So this I am showing like this. I am making an arc like that. For 0 degree ice to become 0 degree water, how much heat will be required? 250 into 80. How much is that?
20,000.
That will be 20,000 calorie. 20,000 calorie. So now I don't have to worry further because this is the heat supplied and this is the heat required. So now looking at this, can we say, will all the ice melt?
No, sir.
Because you require 20,000 calorie, what is available is 10,800 calorie. So what is going to happen?
Some amount of
Ice. When you have said some amount of ice will melt means there will be ice and water in the final mixture.
Temperature
So
is 0.
what is the temperature finally?
0 degrees Celsius.
This part we have found out already. One part we have done. The other part is what we have to find out how much will be left out. So what we can say is heat lost equals heat gained. So heat lost will be by water. Water will lose this much heat. So I can put it here 10,800 and only some amount of ice will melt. So we will not put 250. I will put it as delta M times 80. So can you calculate how much ice melts?
135 grams.
Yeah, that's it. 135 grams of ice melts.
735 grams.
So what you have left out is 115 gram of ice and 600 plus 135, 735 gram of water. That's your answer. Is that fine?
Yes, sir.
Okay, so I'm going to case 2, which is a slight variation on the same question. Have you taken case 1? You will be drawing the if diagram once again and solving a similar question. Let's see. Case 2. The only difference is I have got 1500 gram of water. So I have rubbed off these things. I don't rub off all of this. I will see I made some changes. You draw this diagram once again. So now what is the analysis?
Same.
Amount of ice is same. Only this thing is varying. Let us see what is going to happen now if you mix the two. Then we proceed the same way. 15, 18 za, 270, 00, 27,000 calorie is available if water goes from 18 to 0. Okay? And if this ice melts, what you require is 20,000 calorie. So first of all the ice melt?
Yes, sir.
And it
All
will
the,
also.
all the ice will melt. So no problem. The demand is less than the supply. So you can say what else you want. Well, ice will then go from 0 to a higher temperature. So it will go to some temperature here, which I don't know what is that. It goes to some temperature, which I can call as T degree centigrade. What you can see now is, this will not happen. Water will simply come from there to here. If water comes from there to here, the loss of heat for water will be 1500 into 1 into 18 minus T. Heat lost will be 1500 into 1 into 18 minus T. Heat gained. The black equals the red. Heat lost equals heat gained. Heat is going to be gained first of all 20,000 calorie for melting the ice plus what is the length of this red line? Length I mean the heat required. It will be 250 into 1. Should I put 1 or 0.5? Ice has become water. When ice becomes water, treat it as water. So 250 into 1. Yeah, is that fine? But before you answer this, have you already found something here? One of the two, can you answer?
920.
The mixture is what? What is the mixture made up of? Because at T degree centigrade you cannot have ice. For ice you have to be 0 or below 0. Above 0 it is only water. Okay. So what you have, the final mixture is 1750 gram of water. This part we have answered. Solve for T, answer the second part also. So how much do you get? 4 degrees centigrade you get. Do you get 4 degrees centigrade?
Yes, sir. 4 degrees.
Yeah, that's the answer. Case 2 we have done. We are going to case 3 now. Again, I'm going to do a little change in the question. SI is specific heat of ice. Case 3, you have 2500 gram of ice at minus 10 degrees centigrade. Rest of it is same. So I draw the if diagram once again. Let's start. Yeah, let's go together. So first of all, we will check out that what if all the water becomes 0 degree centigrade. How much heat is available? That will be 1500 into 1 into 18, which we had done earlier also. 27,000 calorie is available if all the water comes to 0. How much heat is required for all the ice to go to 0? 2500 into what? 0.5 into 10. That's right. Is equal to how much? 2500 into 5 is 12,000. Yeah, is it okay? 12,500 calorie. Now, so will the ice go to 0 or not? 27,000 is available and you want 12,500. Okay. Now, supply is more than demand, so it can be fulfilled. All right. What more can happen? What more can happen is, can all the ice melt? Can all the ice, see, when I go above from one phase to another phase, I'm putting an arc like that. So if all the ice melts, what is the required 2500 into 80? So that will be like
That will be 20,000 more.
2 lakh calorie. 2500 into 80 is 2 lakh calories.
Yeah, 2 lakh.
Now can this happen?
No, sir.
No, this is too much. Sorry, it can't happen. Okay, so if it can't happen, then what can happen?
Some of it will
Some of the ice will melt. Some of the ice will melt. We have done this case before itself. So what is the final temperature?
0 degrees Celsius.
That's all. So solve this now and get the mixture. Final temperature will be 0 degrees centigrade and heat lost equals heat gained. Heat is lost by water, which is 27,000 calorie. 27,000 equals heat is gained by ice coming to 0 plus some amount of ice will melt. We don't know how much. Well, that's what you got to find out. So I'll just tell me this much, then you can of course add up and find out. So what is the delta mass? What is the ice which melts? 181.25 gram of ice melts. That's all. I'll just do one more case, the last case in this, so that we are clear on all different possibilities here. The one you were doing just now was case 3. One more to go, case 4. Case 4 contains 100 gram of water, that's the change. 2500 gram of ice at minus 10, 100 gram of water at 18. What is the temperature of the mixture and the composition of the mixture? This is what you want to find out. So make the diagram again. Can you give me the final answer? Yeah?
Yeah,
It will be all ice.
It will be all ice, that's right. It will be all ice. So let me write that. 2600 gram of ice. Well, at what temperature is what you have to find out?
Minus 2.25.
Answer is close, but I think you have committed some error there in assuming the sign convention. It is not 2.25, it is very close to that. but I think it's because of a calculation mistake you have done. You are 99% correct. One mistake is there in your answer. Okay, just tell me how do we go about it? What next? Will water, if it comes to 0, it is 1800 calorie, and if all the ice goes to 0, 12,500 calories. So what do I do with these figures? Can all the ice go to 0 degree centigrade? Yes, no, what?
No, sir.
So what is going to happen? What if all the water condenses? What if all the water condenses? How much heat will it liberate? 100 into 80.
2.25.
Exactly. इसका भी वही.
2.25, is it positive, minus? What are you saying?
Negative.
उसका भी वही.
No, but that's not, wait a minute, that's not the answer. There is some one mistake you're making, I think, because I've heard of that answer earlier.
2.09 minus.
Yeah, what did you say? Come again?
Minus 2.06, yes. 7 minus.
Yeah, that's fine, that's right. Minus 2.1 degrees centigrade is the answer. Now, can we just have a look here? So, all the ice cannot become water because this requires 12,500, whereas what is available is 1800 plus 8,000 is still 9,800, which means water will come still down. If it comes still down, let us assume this temperature as something minus T degree centigrade. I'm assuming T is a positive number. Temperature minus T degree centigrade. So what will be this? How much will be this heat transferred? What's the length of the blue line here? 100 into 0.5 into T. That is right. And ice will come from this point to this point only, which is again 2500 into 0.5 into, what is the gap temperature difference? It will be 10 minus T. Temperature difference will be 10 minus T. Have you put this in your answer? Check that out. People were getting 2.25. You might have done a mistake here.
Yes, sir.
Okay. So now heat lost equals, heat lost is 1800 plus 8000 plus, this is 50T equals 2500 into 0.5 is 1250, 10 minus T, solve for T. I think this one you should be getting as the answer. This you will get as 2.1, 2.09 or something, but I'm rounding it up. Hence we get minus 2.1. Yeah, is that okay? In the 4 different cases, I have examined 4 different possibilities which are there. In this case, yeah, are all the 4 cases fine with you and the if diagram? And you can see the if diagram is nothing but basically trying to visualize the possibilities in a graphical mode.